谢谢。
So please send your team member to write down the message. And I think the accept the challenge question is for the problem solved, right? Okay, the problem is there.
straw shaped into a triangle and cut open at the vertex. When such a triangle is partially immersed in water, one of its vertex is located around its vertical axis. Water may flow out through the straw, and investigate how the geometry and other relevant parameters affect the pumping. And this is my observation in the videos here. The water will flow out from the straw. Two brackets to construct our experiment, and also the electric drill to rotate our straw pump. And this is our 5 different angle straw pump. This the 15 degree, 30 degree, 45 degree, 75 degree, and 60 degree here. And this is our theory. According to the Bernoulli's principle, we can assume that the pumping speed, the water flow out from the straw, the speed of the water flow out from the straw is proportional to the omega, and the angular velocity. And also, this is the theory of the diffusion radius. It's from the projectile movement. And this is our first experiment. The goal is to find out the relation between the straw angle and the diffusion radius. The control variable of our experiment is that this angular velocity, the height of the straw, and the amount of the water, which is 1 liter. And the independent variable of this experiment is the straw angle, and the dependent variable is the diffusion radius. This is our experiment result. But from our theory, we assume the result should be protracted. But in our experiment, it shows that it is not. This is my second experiment. The goal is to find out the relation between the angular velocity and the diffusion radius. The control variable of this experiment is the straw angle, the height of the straw, and the amount of the water. The independent variable is angular velocity, and the dependent variable is the diffusion radius. This is our experiment result. We can see that the relation between the angular velocity and the diffusion radius is linear. And this is my conclusion. The pumping movement can be seen as a projectile motion, just like this. And the angular velocity is proportional to the diffusion radius. And this is my discussion. Why does the water flowing out is drop instead of flow? Like when you see your straw pumping, you see many drops flowing out from the straw instead of a stream flowing out from the straw. And this is because when water flows out from the straw, initially it forms a stream. However, as the water passes through the opening, the action of the centrifugal force will cause the stream to start splitting into drops. And this is my second radius ring is that of the circle. In my first experiment, I found out that the diffusion radius is a range from like a 10 centimeter range, like from 40 centimeter to 50 centimeter. And after that, I found out that it is because of the different radius of the flow. When the radius of when the two radius from the flow is different, the diffusion radius will be different. And if we observe only a few rotations, then we can see that there are two distinguishable centric circles, and that is caused by the different diffusion of the radius. And so from that we can conclude if the radius of two flows is the same, then the range of the diffusion radius will be smaller and similar to a circle. And that is my presentation.
Let's move the next page on the opponent. You have 2 minutes to the question.
Thanks for your report. And well, the length of the straw affects the diffusion radius. Okay, thank you. Well, the material of your straw affects your diffusion radius.
I think the material of the straw will affect our diffusion radius.
And will the density of the water or the liquid affect the diffusion radius?
Yes, the density will.
Okay. And will the water temperature affect the diffusion radius?
I think the water temperature will not really affect our diffusion radius.
Okay. Well, the area of your water surface affects the phenomenon. Will affect the diffusion radius. Your tank. You have a container.
Yes, I think as the tank is big enough, it won't affect it.
And will the resistance of the water affect the diffusion radius?
I think the resistance will.
Okay. Since a small vortex may form on the water when the straw is spinning, so will it affect the system's stability?
I think as long as the water can reach, the straw can reach the water, it won't affect.
And well, the length of the straw has boundary limits, which means that if the length is too long, the water won't come out. If you have a boundary limit.
Yes.
And will the water fill all of the straw?
Well, the water, no, at the edge of the straw, it will be like quadratic.
What about the middle of the straw? Will it fill the whole?
Yes, but at the end it won't.
Okay. And can your theory fit to your experimental data?
Yes.
And did your theory consider the viscosity of the water, or maybe the friction from the straw and the water?
No, because I think that the flow is plastic, so the friction is.
Okay,
Okay.
the opponent has 3 minutes to prepare. You may start the discussion stage.
Honorable judges and fellow competitors, I'm the opponent from Team Excel here, and today I'm going to oppose problem 11, pumping straw. Problem statement: a simple water pump can be made using a straw shaped into a triangle and cut open at the vertices. When such a triangle is partially immersed in water with one of its vertices and rotated around the vertical axis, water may flow up through the straw. Investigate how the geometry and other relevant parameters that will affect the pumping speed. So our main focus will be how is the water pumped by spinning straw and relevant parameters that will affect the pumping speed. And this is the report's outline. First, in the theory part, he mentioned the Bernoulli's principle and the diffusion radius that he calculated. And for the experiment data analysis part, he has done 3 kinds of parameters, which are the height of the straw, the angular velocity, and the amount of the water. And the measurement is the diffusion radius. However, he had no explanation for the deviations. And here are the strong and weak points. For the strong points, he has clear observation video of the rotation of the straw, and he also shows his experimental setup. And some critical parameters is discussed in his reports, such as maybe the amount of water, the length of the water, the length of the straw, and the angular velocity that the straw possesses. And for weak points, he has no clear qualitative explanation of the reason for the phenomenon, and he has no theory line, and he didn't compare some experimental data with the theory, and he didn't consider the viscosity of the water. And he also failed to consider the perturbation of the water, and he didn't consider the resistance from the water. And he has no boundary limits for some parameters, and he has no explanation of the deviations. And here are the points to discuss. I would like to discuss into four parts. And the first part is the parameters, since the important thing that not only the parameters that the report has done will affect the pumping speed, but also other parameters, like the characteristic of the straw, which will be the radius of the straw, and the length of the straw, and also the geometry of the straw, and how the different shape of the water inlet and the outlet of the straw. And then is the angular velocity, and how angular velocity changes the forces acting. And then is the immersion depth, how the depth of the straw immersed into the water will affect the pumping speed. And for the theory part, we'd like to discuss how the forces acting on the water, which will be the centrifugal forces and the gravitational forces, and also the viscosity of the water. And then to the experiment part, we'll like to discuss how the velocity of the water flowing in and flowing out. And then is the diffusion radius and the pumping stability, since the opponent thinks that there might be some deviation caused by the report's setup. And then is the way that the water, or you could say the direction that the water flows into the straw. And for the last part, we'd like to discuss the data analysis, which we will discuss the boundary conditions, and the critical angular velocity, and the critical included angle, and also the critical length or the critical height of the straw. And then we'd like to discuss some experimental errors which may be caused by the report setup, or may be caused by the perturbation or the vortex that form on the water. And then we'll also discuss some maybe the friction that caused by the material of the straw, and some deviation that may be caused by maybe other factors. And thanks, that's all. And okay, and for judges, can I use the blackboard?
Yeah, sure.
Okay, good. And can you explain explain how the forces acting on the water. And what is the direction of the centrifugal? This is straw, right? Yeah. And when it is rotating, what is the direction of the? If the direction is here, then why the oil will flow down in this direction? Can you explain why?
It's we can put it off the force and
the opponent disagree with the report. The opponent thinks that the direction of the centrifugal force is this way, and so that the water will just go through this pipe. Okay. And what determines that whether the water will flow the straw or not?
It is controlled by the angular velocity and the length of the straw.
And how do you mean like the length of the straw? Do you have any experimental data that can prove it or show us?
No.
Okay. And and how do you think will the straw be filled with water? Maybe some velocity, maybe have reach high velocity so that the water will fill the straw.
I didn't measure that.
And do you think it will or not?
I think at a certain velocity, at a certain angular velocity, it also won't fill out the straw because we observed that at the end of the straw, the water surface is instead of filling all the straw.
Okay. And since that the prior statement has asked the pumping speed, and how can it be related to the diffusion radius?
The diffusion, we can measure the pumping speed because when we have the diffusion radius, we can know the speed when water flows out from the straw, and now we can calculate the pumping speed.
Okay. And you calculate in your okay. And what will other parameters affect the pumping speed? Okay, thank you. And since you have mentioned that the length of the straw will have the boundary limits, right?
Yeah.
And what do you think the boundary limit is?
Can you explain what is boundary?
And the wire won't come out the pipe. The wire maybe won't flow like this, but it won't flow. So it will happen. And why it will happen?
Because as the angular velocity is of the water.
But from the formula of the centrifugal force, you know that F equals R and mv squared.
Yeah.
And this is the radius of rotation, right?
Yeah.
And if we change like this, if the radius of the rotation increase, the velocity will increase, right? And then why it will still have boundary limit because the R increase, the velocity increase. Then why do you think that it will have a boundary limit?
Can you explain the question again?
I mean that if you said that if the length of the straw increase, and it will have a boundary limit, which means that the water won't pump out if it reaches a critical height. Then can you explain why?
As the length of the straw increase,
you have a parameter that changes the radius of the straw. Do you think how it affects the pumping speed or the diffusion radius?
I think that as the I think that as the radius of the straw is increased, the pumping speed will increase. However, it will stop at a speed as the radius is going.
Okay, thank you. And how do you think that the immersion depth? This is what the surface, and do you think the immersion depth D will affect the climb?
I think as well as long as the vertex of the straw are soaked into the water, it won't affect.
But you want to think that since the length, you didn't change the length of the straw, right? And this is one parameter, and this is another one. This one has a higher water level, and since the gravitational potential energy that the water needs to overcome, since the water needs to only climb this height, smaller, and this is the bigger height, right? So I think it will be easier for the water to pump up. What do you think?
The shorter.
Okay, thank you. And so, do your experimental setup consider the immersion depth?
Yes.
And how do you control it?
This is the wall. This is the place. Every time we do the experiment, we fill our tanks full, and the here and the depth of the straw is coming.
And then I would like to discuss how the water flows into the straw. And if this is the straw, and right, this is the straw, right? And if it rotates in this direction, then how will, if it rotates in this direction, how will the water flows, the direction of the water flows be the same to the direction of the straw?
I think that.
And will the direction of the water flow, the direction of the straw is like this, and this is the water flow.
I think that
How will the water flow?
because as the straw is rotating, and water from here is faster than here. So we from the English law, pressure from here is lower.
What do you mean like the pressure from here is lower?
It is the water is moving faster. This water is moving faster than this one, so the water is moving.
And I can ask how did it relate to the velocity and the pressure?
From the
Oh, okay, thank you. And why do you think it is appropriate to use Bernoulli's equation in theory?
because
Okay, thank you. And what do you think that in your experimental setup, what will cause the deviation? It means maybe it will affect, so it will not be so correct, and not so accurate. And maybe the voice weather, since there will be a vortex, right? So there will be unstable. So what we call the unstable system?
I think the will cause it, and also the different radius from the two sides. So if you didn't put the stick in the right side.
Okay, and thank you.
Okay, time's up.
And for the discussion summary, the reporters mentioned that the report thinks that the length of the straw won't have a boundary. However, the opponent thinks that the length of the straw will have a boundary, which is won't have a boundary, which is because that when the length of the straw is increasing, the radius of the rotation will increase, so that it will be easier for the water to pump out. And then the report thinks that the turbulence and the vortex may cause the deviation, and the opponent agrees with it. And also, for some critical, the report believes that there will be a critical angular velocity, and the opponent agrees with it. And at a certain angular velocity, that water may almost fill up the straw.
And reviewer, you have 3 minutes to question.
So I'm the reviewer from Team Chapter. I have questions for both the report and so first. Obviously there are multiple parameters that will affect the function. So which one do you think affects?
I think the angular velocity will affect.
Okay.
I agree with the report.
So I have a question for the report about your setting. So you said you use a drill, right? So how do you control your music during your instrument?
Because the drill has different
So thank you. So how do you think you can fix this?
I think it can use a model to maintain the angular velocity of the straw.
The stroke the electric drill can be controlled because I always press to the thing.
So as you're pumping, the immersion depth of the water will decrease, right? So obviously that will affect your rotation. So how do you think you can decrease this?
I can make the tank much bigger, so the decreasing height will less away.
And I think we can fix the model with the aluminum extrusion to minimize the vibration. And with the aluminum extrusion, we can also control the immersion depth for the setup.
Okay. So question for the reporter. So do you think that the inertia of the straw will affect the function?
The what?
The inertia of the straw will affect the function.
Can you explain?
So inertia is a thing that is 10 times higher squared. So that is what happens when there's split. So do you think that will affect your function?
I think yes.
And the report thinks that if the model gives the straw a constant angular velocity, that because it's the same angular velocity, the inertia won't change the phenomenon. It won't change the results.
So last question for the do you think that you should consider the viscosity of the water?
What?
The viscosity of the water earlier. So why?
Because
Okay, thank you. So what?
I think it must consider the viscosity of the water, since the formula of the turbulence flow or the laminar flow, so we'll consider the viscosity of the water. So I think it is.
You have 2 minutes to prepare. review.
Okay, so hello everyone, I'm the reviewer from Team Chocolate. Today I'll be talking about February 11th from Team Chocolate. So first of all, let's talk about the reporter. So he has some points to implement in his presentation. The first one is he has numerous variables considered during his experiments, and he also highlighted pain points and problems. Last is he noticed small details in his experiment, including the water being sprayed out by droplets. However, there are some points of concern where the theory wasn't explained thoroughly by the reporter, and he doesn't have a clear definition in his diagram also. And his layout of the report needs some improvement. So as for the opponent, he has understood the reporter's presentation to a certain level, and he also mentioned some flaws during the reporter's presentation, including the lack of qualitative explanation. However, he also has some areas of improvement. I think he too focused on the reporter's theory, and he lacks the discussion in the experimental setup. As for the question and answer, the opponent first asked the reporter whether the material affects the diffusion gradient, and the reporter answered yes. And next, the opponent asked whether density and temperature affects the diffusion gradients as well. As for the density, the reporter answered yes, but for the temperature part, the reporter's confused. The third question the opponent asked is, will the length of the straw have a boundary limit? And the reporter agreed that it has a boundary limit. And the opponent also asked whether the viscosity affects the results. And the reporter agrees with the opponent. And the last question the opponent asked is, was friction considered during the reporter's experiment? And during their discussion, the opponent asked what are the forces in the experiment, like they discussed on the blackboard, and including the direction of the centrifugal force. And the reporter said that the centrifugal force should be faced inwards, but this contradicts with why the water flows out, which he thinks is strange. And also, the opponent mentioned what the boundary limit should be. For the reporter, he knows that there is a boundary limit, but he couldn't quite explain it. And next is the question from the reviewer. So I first asked it, can the rotation speed of the drill be controlled? And the reporter didn't answer, but the opponent says yes. And my second question is, do we need to consider the viscosity, how it affects the results? And the reporter also didn't answer, but the opponent said yes, we should. The theory proves the viscosity. My second question is, how do you decrease the impact for the rotation speed while the inverse step is dropping? So the reporter still answered my question. And the opponent says that use a motor and add extra things to his setup should add the luminance to minimize the vibration. And this might end up my presentation.
Reporter, you have 2 minutes to conclude.
From the reviewer and the discussion, they both agree that the angular velocity affects the pumping speed at all. And the opponent also stated that the immersed height of the straw will affect the pumping
question for you. What's the most important method for pumping out the water? How you distinguish between the ballooning effect and oversaturation effect? How you distinguish the pumping force in the original form, centrifugal effect or ballooning effect?
I think both of you mean the centrifugal force and the balance principle. I think they will all impact the phenomenon, the results. And for the centrifugal force, which is the quantitative explanation for that, the water will comes out. And for the balance principle, we can have quantitative theory model. So we can have a theory, which is from the Bernoulli's principle.
So the reporter, how you distinguish between these two effects?
I think the reactive force affects the pumping speed more.
I think for the water rising, it's still inside the straw. For the water rising, the centrifugal force is the main reason. But when it starts to pump out of the straw, I think that the Bernoulli's law acts more on the water.
Any other questions? Okay, so you all mentioned about the viscosity. So what exactly is viscosity play in the pumping? What's the role of the viscosity?
I think viscosity stands for the attribute of the water. If the viscosity increase, which will the viscosity of the water will be considered, so that it will, if the viscosity of the water increase, it will be harder for the water pumps out.
I think as the viscosity increases, the water will be more easier to flow out from the straw, and that will increase the pumping speed.
So I think the water the viscosity affects, because as the viscosity increases, the harder for the water to move out.
So you all consider the difficulty arising from the original from the viscosity. How large is the water viscosity?
Pardon?
Is the water viscosity at 16 value?
What do you mean? What's really?
Is viscosity of water, is it really big?
What do you mean really big?
Is it important?
I think it is important for a theory for a theory part. It is important. It will affect the phenomenon.
The viscosity of water is very small.
I think it's the viscosity of the water change. Since that when the water temperature change, the viscosity of the water will change. So I think it will impact the whole result.
I think I want to change my answer. I think as the velocity decreases, the water will be easier to flow out, and the velocity and the viscosity will impact the pumping speed.
I think there are multiple parameters that affect this, so such as the rotating speed and the angle of the straw, or the immersion depth, or the exposed depth. So viscosity might not be such a major influence in this experiment.
Any other questions? If there are no other questions, let's prepare the final score. 4, 5, 4, 4, 5. And then let's go for the opponent. 8, 7. Okay. And then finally, let's go for the reviewer. 6, 8, 6, 8, 6. Okay. So we have another 10 minutes left. And